Okay, first I want to say that formula for magnetic field is obtained experimentally. It's not derived from some other formula. Usually it's derived, some formula are derived from some other formulas, but for magnetic field it's obtained experimentally, and I will try to guide you across process of derivation. So let's say that we have some wire, and that wire is perpendicular to screen, and if current goes into the screen, I will put a dot. If current comes out of the screen, I will put a dot. This is just a convention how I'm going to draw. So let's say that we have a wire, and around that wire we have some magnets, and if we have a current now through that wire, the magnets will align with the cycle around the wire. And actually when we have a current through wire, there is a magnetic field around that wire, and we can determine that magnetic field with right hand side rule. And if we wrap that wire and thumb points in direction of the current, the fingers will point into direction of magnetic field. And now and this is experimental fact, and now let's see let's take a wire and put into magnetic field, and this is now experimental fact that the force on this wire is proportional to the actually the force is cross product of current through that wire and magnetic field. So in this situation here, the force on this wire will be up, but if we have a current which goes into the screen, the force will be on this wire, it will be in this direction. Now let's say that we have, this is all experimental facts, and now let's say that we have some charge Q, and that charge has some velocity v, and if it's in magnetic field, that charge, scientists observed that the force on this charge is actually perpendicular to the speed. So the force is perpendicular to the direction of this charge. And they also observed that force is proportional to the amount of that charge and proportional to the speed of that charge. If speed is larger, the force is larger, and same true is for Q. And they observe those facts, and the formula for magnetic field is, you can guess, is that the speed cross magnetic field B times Q. Yeah, simple, right? And of course, after that they have to verify that, they perform some measurements, and this is how they derived formula for magnetic field. This is a Lorentz force. Now, this is a force for, let's say, for this some point charge Q. But now let's see the force on some wire, some length, L. Doesn't matter. Now let's say that this is some wire, and we have a current through that wire, and this wire is some magnetic field B, and now we have this charge Q, and it goes in this direction like this, and it has some speed V. And of course, now we have some angle here between the speed of this charge and the magnetic field. Now we have some small amount of, and now we are trying to measure for this small, so for this Q here, so we have some small force here. It's equal to, of course, this charge times V times magnetic field B. And the formula for charge for electric current is delta Q delta T, but we can write it delta Q is delta T, it's equal to delta Q. This is delta Q, this is some small delta Q, right? And we can replace this, so we can write that it's equal to current times delta T times speed of that charge times magnetic field at this point. This magnetic field actually doesn't have to be the constant, it can vary with the position, and yeah, and now if we want to calculate the force on this wire, we need to integrate this, and this can be, of course, quite tricky, right? Because we have a dot product, we have a angle here between the wire, between the magnetic field and the speed and the velocity of this charge. But this can be actually, we can simplify this, and we can write this here actually. This can be written like this actually, because here we have this here time and the velocity actually is the distance, so we have dl here, and we can write as a times dl times times magnetic field. So let me write here that the force actually is equal to current times dl. This is the vector still, and magnetic field. And this integral can be quite complicated, as I mentioned, because we have to take into account the angle, and this magnetic field, maybe it's constant, maybe it's not, and it's not easy to evaluate this integral. Okay, so let me mention one more quite interesting thing, is that the magnetic field can't do work. Electric field, yes, but magnetic field, no. So this is interesting. Let me explain. So let's say that we have some constant magnetic field like this, and let's say we have some, I don't know, some charge here, charge q, and this charge q has some velocity v. My drawing is awful, but and now let's imagine that this q, it's now here into this magnetic field, which is constant. And as I mentioned earlier, that the force of this charge will be perpendicular, and what will happen with this charge, it will start moving like this into circle. So, and if there is no loss of energy, there is no friction, there is no, I don't know, so there is no air, it will move into cycle forever. And this is quite interesting, at least for me. And now let me try to explain how does an electric motor work. Okay, let me try to draw. Okay, let's pick another color. So okay, let's say that we have a wire like this, and here we have brushes. Yeah, okay, and there is a gap between brushes, but it's smaller. Yeah. And we have a battery, right? We have power supply here, and current go like this, right? This direction, into this direction, and this direction here, like this. And now of course this wire is in constant magnetic field B, and current go in this direction, right? We have magnetic field which is perpendicular here to the wire, and this will cause force in this direction, here in this direction. Here, because it's polar to magnetic field, will be 0, and here will be 0, and here will be 0. And this force here and this force here, the net force is 0, but there will be a torque on this wire, and it will start moving like this, and the force will be less and less, but because of the moment of inertia, it will switch here, and current will start go in opposite direction, and the force will continue, and this wire will start spinning around. So basically that's how how does an electric motor work. Yeah, that's it.